Hi everyone, Hasan is here with great Azure Cosmos DB news for you. As you know, Azure Cosmos DB scales horizontally. This means that your data is distributed across multiple database servers. If you organize your data correctly using an appropriate partition key, your queries can run on a single database server. However, even with a well-defined partition key, you may encounter situations where you need to query data without it. Let me show you an example here. As you can see here, we are actually saving here our sales under orders container, and our partition key is customer ID. Looks like we have 2, 4, 6 servers our data is distributed to, and since our application always have the customer ID available, we are not having any kind of cross-partition problems here. Most of the time, we know, well, Cosmos DB knows where data is because we have the customer ID in the query. And as you can see, our cost is not that bad, 9 request units. So everything is working great here. But, business changes, business evolves, and they are going to come up with different requirements. So our warehouse sends a requirement, and they want to actually see this data per product ID, not the customer ID. So they want to see all the orders per product. Then, that's not a big issue for me, right? All I have to do is I just change my query and, everything should work. Well, I will have the data, it will work, but the problem is when you look at the database level in Cosmos DB, well, we have a situation here. It used to cost only 9 request units, and I was able to get all the data I need from one physical partition or the server. Now I don't have the customer ID anymore, so guess what? This query becomes a cross-partition query, and it jumps from 9 request units to 49 request units, which is a big jump. So how do we fix that problem? That problem is a common problem of any NoSQL, any kind of distributed databases. So usually we tackle this problem with the materialized view pattern. Materialized view is what you really do here is you take the data from the orders and you duplicate that in a different container, maybe with a different partition key, or maybe you change the data model a little bit. So a problem like that comes up, you don't have to kind of worry about the model's shape or the partition key. So materialized view is a great option for that. Well, materialized view is great, but it can take some time to actually figure that out because you need to write a code which is going to take all the way this data and put it in the different container, and you want to be sure that that's always going to run and everything is going to sync. So there's some, it's a pipeline at the end, and you kind of need to watch, if anything fails out there. Well, if you are using that or if you are having this problem, I have great news for you. Cosmos DB team actually bring a new feature to us. The name of the feature is Global Secondary Indexes. Global Secondary Indexes really another type of container. And you can only declare them. You have to have a source first, and source is going to be one of your containers. And from the container, you're going to just create a global secondary indexes out there. So Cosmos DB is going to actually take all of that information from your source container and move it to your GSI container. And you don't need to write any kind of line of code out there, and everything is going to work magically simple. So GSI containers are really just another type of container. They have all of the index policies. It has a partition key. It has request units, so you can scale up and scale down as much as you like. The only difference is they are read-only, which means you cannot go and change the data manually. So Cosmos DB's process is the one which is going to sync all the data. So if you look at, the overall, this is how it looks like. The data comes in. In our case, it's the orders. We have the partition key, customer ID. And from that point, GSI container, all that, the computing happens in the backend. You don't really see anything. You don't need to write any code. On top of that, that computing is actually free too. Cosmos DB is not charging you for that. And data becomes available in the GSI container. So you can use it in any situations, just like I showed you. So let me actually show you how easy to generate or create one of these global secondary indexes. For that, I'm going to go to Azure portal. Let's see here. Now, in here, I have the Stack Overflow database in one of my Cosmos DB samples here. So as you can see, I'm having some kind of like the simple or the same kind of situation here. As you can see, I have the posts container, and my the partition key is post ID. So which is great because all the inserts are working great, very fast, since each post ID is very unique. But whenever I try to get the data by user, for example, if I want to get, for example, this one says owner user ID 5. If I want to get all the questions or answers by that user, that becomes a problem. Just like the orders problem we just talked about. So to fix that, I can just create a global index container. To do that, all I'm going to do here is I'm going to go click on that menu here and click on the new global secondary index. Then I'm going to have this window comes up. The source, as you can see, is the pod. And I just need to give a name to this global secondary index, which let's say posts by user, makes sense. And this is the filter. That's how you control how many properties you want in it, or do you want to put like any kind of filter here? Maybe like, for example, you want only the questions, only the answers. So depending on your business really requirement out there. So I'm going to put everything here. I don't really care. I want exactly the same posts data model in the this new container. All I'm going to do is I'm going to change my partition key so I can actually use the user ID. So it will be much cheaper and scalable to actually run in this way. As I said before, this is at the end is a container, so you can easily scale up and scale down here. By default, it's the auto scale 4000, but you can change it if you like. And there are many other options here. You can keep your vectors out there. You can do full text, so you can customize it as much as you like. So I'm going to click. Well, I'm not going to click OK because this is going to take some time because I believe in my posts container, I think I have like more than 2 million documents. So that's going to take some time. You kind of have to wait until it's, catch up. So I already done that before. So let's actually let's jump into my VS Code extension here. And as you can see, I pick my database, Stack Overflow. And so first, let's go to the posts and look at the, how many documents we have. So it should be the same number, more than 2 million. So this is great. Now, the first thing I told you, the partition key is the post ID. So even if I'm going to try any kind of query like this, I want to get all the questions by this user and execute that. Well, this is going to take some time because it's almost like 21. The main reason is I have 5 different partitions, 5 different computers. So when I run this actually runs and executes in each of them, and each of them cost me a request in it. If you want to actually see that under the execution metrics, you will see number of requests is 5. If you click on it, these are the documents I received from each of them. This one is the worst because it returned nothing, but I'm still, getting charged almost 4 requests on this. So I want to fix this problem by using the global index containers. So what we did create a new container, the index container, and posts by user. So if I'm going to actually pick this one, and let's be sure we have the same numbers. First, it was more than 2 million. This is more than 2 million, so we are good. Now, I'm going to go and actually execute the same exact query. Since I copy everything to the new global index container, I should have the same data. As you can see, I got 31 items. The request charge is much more acceptable now and affordable now and more scalable now because I am not, dealing with 5 different physical partitions. So as you can see, it's very useful. You can use this in many places in your solutions. And also, one more thing, you can have many global index containers. It doesn't have to be one. So if you need 2, 3, 4, you can do that. And I really like this new feature of Cosmos DB. I hope you will too. If you have any questions about it, please just write a comment under this video, or you can reach me from the social media. I can try to help you with any of the problems you might have with this feature. Thank you for watching me, and I hope you will have a great day. Thank you. Take care.